Hello again! This is the third installment in Math Together Canada's problem-solving series. Today, Kaylin and James will be going over problems 7 and 8 from the 2024 Euclid contest. These problems are markedly more difficult than the first 6, so be ready for an exciting and challenging video. Kaylin will start us off with problem 7.
Okay, so this is problem 7 from Euclid 2024. Problem 7a says, Arun and Bella run around a circular track starting from diametrically opposite points. Arun runs clockwise around the track and Bella runs counterclockwise. Arun and Bella run at constant but different speeds. They meet for the first time after Arun has run 100 meters, and they meet for the second time after Bella runs 150 meters past their first meeting point. What is the length of the track? So first we can draw out a diagram of this track. So let's say that this is where they're running. And we can label 4 points. So let's call this point A. I'm gonna write that over here. So this is A and this is B. So these 2 points signify where Arun and Bella start. So A is for Arun and B is for Bella. And we know that Arun runs clockwise and Bella runs counterclockwise. So Arun goes this way and Bella goes this way. And they meet for the first time somewhere on that half of the circle. So let's call the first meeting point M1 and let's label it over there. So we know that M1 is after Arun runs 100 meters, so we can say that this length is 100. And if we let BM1 be equal to x, then that means that the length of the track, I'll write that out, length of the track is equal to 2 times 100 plus x, because 100 plus x is equal to half of the track. So then we can label up a second point, so let's call this point M2, and this is where Arun and Bella meet for the second time. So this is when Bella runs 150 meters past their first meeting point. So because this is their first meeting point and Bella runs in this direction, that means that this length over here, AM2, is equal to 150 minus AM1, which is 100. So that means that AM2 is equal to 50. And because we know that half of the length of the track is 100 plus x, we know that BM2 plus AM2 is 100 plus x, so BM2 is equal to 50 plus x, right? So now we have 4 lengths, and we know that Aruna and Bella run at constant speeds, so that means that we can take ratios to find x. So for the first meeting point, 100 over x, 100 over x is the ratio of Arun to Bella's speeds, and this is equal to the second meeting point. So after they meet for the second time, Arun runs 100 plus x plus 50 plus x, which is 150 plus 2x, and Bella runs x plus 100 plus 50, which is 150 plus x. So this is a second ratio that we can write for their speeds. So now we can cross multiply to solve for x. So 15000 plus 100x is equal to 150x plus 2x squared. So moving things around, 2x squared plus 50x minus 15000 is equal to 0. So we can divide both sides by 2 to get x squared plus 25x plus, or minus, 7500 is equal to 0. So now we can factor this to see that x minus 75 times x plus 100 is equal to 0. So obviously x can't be negative, so that means that x is equal to 75. So we want to find the length of the track in this problem, which we already said is 2 times 100 plus x, which is 2 times 100 plus 75, which is 350. So that is our answer to 7a. Okay. Moving on to 7b. Determine all angles theta for which 0 degrees is less than or equal to theta is less than or equal to 360 degrees, for which 4 to the power of 1 plus cosine cubed theta is equal to 2 to the power of 2 minus cosine theta times 8 to the power of cosine squared theta. So I'll copy that down over here. 4 to the power of 1 plus cosine cubed theta is equal to this. So first, we can write everything out in terms of powers of 2. So 4 is equal to 2 squared, so the left-hand side is equal to this, which is also equal to 2 to the power of 2 plus 2 cosine cubed theta. And this is equal to the right-hand side, which is 2 to the power of 2 minus cosine theta times 8 is equal to 2 cubed, so 2 cubed to the power of cosine squared theta, and this is equal to 2 to the 2 minus cosine theta times 2 to the 3 cosine squared theta. So now we can write this out as 2 to the 2 plus 2 cos cubed theta is equal to 2 to the 2 minus cosine theta times 2 to the 3 cosine squared theta. And we can take log 2 for both sides to see that 2 plus 2 cosine cubed theta is equal to 2 minus cosine theta plus 3 times cosine squared theta. And we can cancel out the 2's on both sides and move everything on the right hand side to the left hand side. So 2 cosine cubed theta plus minus 3 cosine squared theta plus cosine theta is equal to 0. And now we can factor this. So first we can factor out cosine theta. So 2 times cosine squared theta minus 3 cosine theta plus 1 is equal to 0. So cosine theta times 2 cos theta minus 1 times cos theta minus 1 is equal to 0. So now either this is equal to 0, this is equal to 0, or that is equal to 0. So if cosine theta is equal to 0, then theta can be 90 degrees or 270 degrees. And if 2 cosine theta minus 1 is equal to 0, then cosine theta is equal to 1/2. So theta is equal to 60 degrees and 300 degrees. And finally, if cosine theta minus 1 is equal to 0, then cosine theta is equal to 1. So theta is 0 degrees and 360 degrees. So we have 6 possible values for theta, and these are 0, 60, 90, 270, 300, and 360 degrees. So these 6 are our final answer. And this is question 7a and b. So now I'm gonna pass it over to James, who's gonna do question 8.
Okay, so let's move on to question 8 then. So you're given a diagram where there's a circle with center A with radius 4, and that A lies on another circle with center B with radius 3, and that there's a line passing through A and B that's perpendicular to MN at point T, and MN is also tangent to the larger circle with radius 4, and that MC and NC are each tangent to both circles at points D, E, F, G as shown. So we want the area of MNC. So what we can immediately do is by dropping the perpendiculars from the centers of the circles to the tangents. For example, draw BE. We can also draw BD. Well, yeah, we can draw BD. Sorry, I'm just trying to make it like not look like it goes like it's tangent to circle B. Anyway, so you have this, and since the lines are tangent, you have that these are 9 degrees. Now, you have that this circle has radius 3, this circle has radius 4. So we can quickly label some lengths. And we immediately see that these two triangles are similar by AA. So because BE is parallel to AD, so triangle CEB is similar to triangle CDA by angle-angle similarity. So we have some ratios then. And usually when you have like similar triangles like these, and we have a few lengths like this, we can try setting a variable, for example, for BC, set to be equal x. And since we have all those ratios from the similar triangles, we can solve for x. So let's just say CB over BE, for example. So CB over BE is equal to x over 3. And since these triangles are similar, this is also equal to CA over AD. So this is equal to x plus 3 over 4. And then you can solve for x by just solving the equation. So you have 4x is 3x plus 9. So x is equal to 9. Now that we have this condition, we can remove the x variable and just add 9 so that things are clearer. Okay. So basically we have x is 9. We can easily solve for the height of the triangle, which is CT. So since the area of the triangle is determined by base times height divided by 2, and we already have the height, that means that we want to find the base. Note that mn is equal to 2 times mt, because due to the lines being tangent to the two circles, this triangle is isosceles, and since this is 9 degrees as well, because it's tangent, mt equals tn. So if we just find what mt is, then we're done. So basically, let's consider the big triangle then, not the big triangle, like triangle CMT. So when you look at triangle CMT, you notice that, well, this angle is 90 degrees, and it has an angle MCT, which is also equal to the angle in the triangles like CEB and CDA. So we have that triangle CMT is similar to triangle CBE by angle, because you have angle MCT is equal to angle MCT, obviously, and the two triangles also have another 90-degree angle. So they're similar by angle similarity. So we have that BE is equal to 3 and BC is equal to 9. We want to find MT when we have CT. So one way we can do this is by calculating CE using the Pythagorean theorem. And CE is equal to 9 squared minus the square root of 9 squared minus 3 squared. So it's the square root of 72. So it's equal to 6 root 2. And since these two triangles are similar, then the ratio between the legs of the triangles, like CE over BE, is also equal to CT over TM. And since we have 3 of the values here, the only value we're missing is TM, we can solve for the value of TM. So let's just substitute the values that we know. So CE is 6 root 2, right? BE we have is 3. It's just the radius of the circle center at B. CT is 9 plus 3 plus 4 because we solved for CB earlier. So 9 plus 3 plus 4 is equal to 16. And TM, well, that's what we're trying to find, right? So this. And this ratio, 16 over TM, is equal to this ratio. And this ratio is clearly equal to 2 square root 2, right? So we can then solve for TM because we have 16 over TM is equal to 2 root 2 using like the usual methods. And we can get TM is equal to, I believe, 4 root 2. Okay, so we have TM is 4 root 2. We established that TM is half of the base, which is MN. So that means MN is equal to 2 times TN, which is 8 root 2. Let me zoom out so you can see everything clearly. 8 root 2. So for triangle MNC then, you have the base, you have the height. Then you can quickly find the area by just doing base times height over 2. So the area of triangle MNC is equal to MN times CT over 2. And we have MN is 8 root 2, CT is 6 root 2. So MN times CT is equal to 96. Wait. CT is not 6 root 2. I accidentally read the wrong value. CT is actually 16. So 16 times 8 root 2 is MN times CT, and that's equal to 16 times 8 root 2. That's 128 root 2 divided by 2, of course. And then we're done. So as a quick recap then, we first use similar triangles based on the parallel tangency lines to find CB so that we can find the height and so that we can also find CE, which we then use in another pair of similar triangles, CEB and CTM, to find MT. And since we have MT, we can find MN because MN is just double MT. So we have the base MN and we have the height CT because we have CB, BA, AT. You just add them all up. And then the area of a triangle is just base times height over 2, so we're finished. So the answer to question 8A is 64 over 2. Moving on to question 8B then. So you're given a system of equations of triples x, y, z that are solutions to the following you're just given a system of equations And yeah, so the first thing you might try is the change of base, because obviously not all of the numbers here are in the same base. So you want to change, let's just consider first equation first. Log 9x plus log 9y. You want to change the base of the third term, log 3z, such that it can have the same base, which is 9, as the other two terms, so that we can simplify calculations, or simplify the expression. So log 3z is equal to log 9 of z squared, because 9 is 3 squared, and yeah, so it's log 9 of z squared. Or if that doesn't seem intuitive to you, you can also just use the change of base formula. So log 3z is equal to, say, log 10z divided by log 10(3). And you can multiply numerator and denominator by 2, because you're trying to turn the base into 3 squared rather than a 3. And 2 log 10, 3. And this is equal to log 10 of z squared divided by log 10 of 9, using basic logarithmic properties. Okay, and now we can just apply the change of bases formula to get that this is equal to log 9 of z squared. I feel like you should probably also include parentheses around the z squared so that there's no confusion. Like, people might think it's log 10 of z and then squared. So you should probably include parentheses around this just to make sure that there's no confusion about what it's equal to. So yeah, you can get log 3 of z is equal to log 9 of z squared. And this is equal to 2, right? But since you have that all of these are under the same base of 9, we can use the logarithmic properties to get that the left-hand side is equal to log 9 of x times y times z squared. Because if you multiply what's inside the logarithmic expression, you get the same value as if you add them separately. That's a really bad looking x. So this is 2. And now we can do the exact same thing for the other 3 equations, right? We have, like, for the second term here, the base is 4, but we want it to be 16. So we can just get log 16 of x. And you can use the same method as before, or just like intuition it, to get log 4 of y is equal to log 16 of y squared. And then plus the last term, which is unchanged. Equals 1. And using logarithmic properties, this is equal to log 16 of x y squared z is equal to 1. And now you just use the exact same thing for the first two equations that we did. And well, since the method is pretty much the exact same, I'm just going to quickly write down what you should end up with. But basically just do the change of base thing as I showed here. So to put all of them under the same base, and then you should be ending up with this: x squared y z equals 0. So basically we have these three equations. Now, we can simplify these equations by noticing that, well, you only have one logarithmic term on the left-hand side and a constant on the right-hand side. So we can just remove the logarithmic term by taking the power of 9, for example. Like we can do 9 power the left-hand side is equal to 9 squared here. And since the 9 power log of 9 of xyz squared is by definition just xyz squared, we can get that xyz squared is equal to 81 because it's 9 squared. Now, let's erase what we wrote earlier so that there's no confusion. But basically, you just do that with the other two equations. So you get xy squared z is 16 to the power of 1. So that's 16. And x squared yz is equal to 25 to the power of 0. That's just 1. So when we're faced with a system of equations where like all three expressions are symmetric, like xyz squared, xy squared z, x squared yz, the most common method that, well, maybe not necessarily most common, but like a very common method that you would use is to multiply the system together. So you get x power 4, y power 4, z power 4 is equal to the product of the right-hand side, which is 81 times 16. That's equal to 1,296. And so x, y, z to the power of 4 is equal to 1,296, which is equal to 6 power 4. Okay. Since we're not dealing with like complex numbers and stuff, we don't really have to worry about any other roots other than x, y, z equals 6. Because, yeah, x, y, z is real numbers, so can't have any imaginary numbers going on to make any other roots for x, y, z. So yeah, x, y, z equals 6, and then you can just proceed by dividing the first equation, x, y, z squared equals 81, by x, y, z equals 6, to get z equals 81 over 6, because the x and y's cancel, and that's equal to 27 over 2. Y is equal to 16 over 6. That's equal to 8 over 3. And x is just equal to 1 over 6. So yeah, the final answer you should get is xyz is equal to 1 over 6, 8 over 3, and 27 over 2. And if you check the original equation to make sure there's no like extraneous solutions you somehow added, like somewhere along the way, you can check that, okay, 1 over 6, 8 over 3, and 27 over 2 does indeed satisfy the original system of equations, and you're done this question. So as a quick summary, for each equation, you notice that there's two bases that are equal, but one of them is the square root of the other two, right? So you can just change the base, whether by intuition or by using the change of base rule, to put every term on the left-hand side under the same base, and then you can just use logarithmic properties to simplify the equation into a symmetric expression where you can just use the common method of multiplying all the expressions together, and then you should get the equation x y z equals 6, and then you can just divide each of the expressions on the left hand side in the earlier system of equations by x, y, z to get the values of z, y, and x. So yeah,
Thank you for watching this video, and we hope you've learned something new today. Make sure to like and subscribe so you never miss out on any of our future videos.